Hi again everyone, Chris Tisdell here again. In this presentation I'm going to continue my series of videos on calculus. In this presentation I'm going to do an example involving integrals of powers of trig functions. Okay, so I'm going to show you how to break down an integral involving powers of sine and cosine, and you would see this kind of example in a Calculus 2 course. So let me share my screen with you, and we can get down to business. Actually, let me just adjust my mic volume a little bit more. Okay. All right, so this is the example that we're going to look at. You can see the font's huge in this example. One of the reasons is I'm trying to get better exposure on mobile devices. So if you're watching on a mobile device, please let me know your comments. Okay, I is defined to be the value of this definite integral. And you can see that there's powers of sine, there's powers of cosine, and we're integrating with respect to the variable theta. Okay, so how do we do it? Well, you can see that this power is an odd power. Now, this is important because what we're going to do is take one factor of sine out of there and move it over and match it up with the d theta. Then what we'll do is try to turn everything that's left over into a power of cosine. And you might think, well, why would you want to do that? Well, I'll show you as we go along. Okay, so let's take out a factor of sine, move it over to the d theta, and then we'll actually, even to signify it more, I'll put some square brackets around what's left. Cos squared. So we've got sine theta d theta over here. Okay, so let's make what's left a power of cosine. Okay, so why would you want to do that? Well, we'll see as we go along. Okay, how can I've got a sine squared, how can I make that something involving cosine? Well, the easiest way to do it is use the old chestnut, cos squared plus sine squared equals 1. So I can change the sine squared to 1 minus cos squared. Okay, so now it looks like it's getting more complicated, but actually it's getting a little easier. If I expand this out, I'm going to get 1 cos squared there and then negative cos to the power 4. Okay, so let me just continue. So if I expand that out, I'm going to get cos squared, and if I go with the sine, I'll have the following. Okay, and now it looks almost complicated, but actually it's simpler. Let me show you. Here we've got the integral of cos squared sine. Now, sine is almost the derivative of cosine, right? Just with a negative sign. Same situation over here. Forget about the powers. Sine is almost the derivative of cosine. Now, what you can do in both of these cases is a substitution, say u equal cosine theta, and break this down to some simpler integrals. What you'll get if you do that, and I'll show you where this comes from in a minute. This first part is going, when you do the integral, it's going to become something like cos cubed theta. Okay, but you touch it up with a negative 1/3. Okay, over here, it's going to go to something like cos to the power 5. You've already got a negative sign out there. You're going to get this. Okay, now you might think, well, Chris, how did you go from here to here? Well, you should be able to write down the answer, but if you can't, I'll show you exactly how, say, I got the first part after I've actually just finished the final part of the problem. Okay, so bear with me. Okay, so now it's just like any standard thing. You put in the values. When theta equals pi on 2, both of these things are going to be 0, so you've only got one thing to worry about. When theta equals pi, this is going to be positive 1/3, and this is going to be negative 1/5. So you actually end up with 2 on 15 after you simplify. Okay. All right, but you're thinking, hang on, Chris, how did you go from, say, here to here? And how did you go from here to here? Let me show you. Let me show you. Okay. Okay, so let's just make it a definite, just an indefinite integral. Let's say I'm just doing the first part. Okay, the second part's similar. Cosine and sine, well, sine's almost the derivative of cosine. So I'm going to let u equal cosine theta. So if u equals cosine theta, what's du? Du equals negative sine theta d theta, because the derivative of cosine is negative sine. Okay, so what I can do now is I've got this here. That's almost that. Just take the negative sign to the other side and replace that with negative du. Replace cosine theta with u, so I'm going to get a u squared here. So I'm going to get u squared times negative du. Take the negative out the front. Okay, I can integrate u squared. That's easy. Okay, just forget about the, I'm going to forget about the constant. And then u equals cosine theta, so that's negative 1/3 cosine cubed theta. Okay, let me move that up a bit. All right, that is how we got that thing right there from that. Okay, it's the same integral, but I've just taken an extra couple of steps to do it. Okay. Now, once you get into the groove with these problems, you'll forget about this. Okay, I wouldn't recommend this. Use substitution only as a last resort. Okay. Now, if you want to go from here to here, again, let u equal cosine theta, and you'll do an integral similar to this, but you'll have a u to the power 4 there. Okay, so that's where this thing comes from. All right. Okay, so just to recap, we had a product of powers involving sine and cosine. We identified the odd power, and we moved one of the terms out, or the factors out, to the d theta. The next step was to get everything as a power of cosine theta. So we did that using the old chestnut, cos squared plus sine squared equals 1. All right. We then had some integrals of this type, where you've got a power of cosine with one sine, or a power of cosine with one sine, and you can essentially write down the answer. If you want to do it the long way, you can use substitution, but I wouldn't recommend that. I mean that with 2/15ths. Okay, if you want to look at the long way by substitution, you can add these steps, but I wouldn't recommend it unless you're desperate or very suspicious of my methods. Okay, so that's my example on integrals of powers of cosine and sine. There's a standard thing going on there for the odd power, and take one of the factors out. If both powers are odd, it doesn't matter which one you choose. So let's say we had sine cubed cos cubed. I could move one of the sines over or one of the cosines. It doesn't matter. Okay, So I hope you enjoyed this presentation. Hope you found it useful. If you have any comments or questions, you can put them in the comment section below. If you're watching on a mobile device, please let me know how you go with the font if you can read it, okay? Because I'm trying to get better exposure on mobiles with my maths. All right, thanks again. See you later. Bye.